Welcome to this third video now on hypothesis testing. In this video we're going to look at one-tailed test, or one-tailed tests I should say, plural. Now there's a few things to follow that we've been building upon on the previous two videos, and these are, I'll run through these now and then we'll go through them in a couple of examples and questions. So first thing we need to do is mention the test statistics. So test statistic, and this might be as simple as X represents the number of heads shown when a coin is tossed, or Y represents the number of patients in this trial where the drug was successful, or whatever the question is essentially talking about. That's what your test statistic is going to be, what you're testing. And if it's binomial, you'll also need to mention the probability, like P would be the probability of success maybe, or you might be mentioning lambda in later questions. So that's the first thing you need to mention. Now the second thing you need to do then is identify the suitable H0 and H1, your null and your alternative hypotheses. So we start the third part with assuming that the null hypothesis is true, and then you would write down your distribution for that, and then we need to calculate the probability. Now we can do this in one of two ways. We can take the value that is within the question and we can calculate the probability of that value happening and then compare it to the significance level that is given. Alternatively, what we can do is we can find the critical region for this question and then compare our value, so see whether our value is within the critical region or not. And then finally we need to write a conclusion. Now I would always write an initial conclusion just essentially mathematically, saying whether there's enough evidence to reject your null hypothesis or that there's insufficient evidence to reject the null hypothesis. Okay, after that initial bit I would then put that into context. So into the context of the question. So that bit you need to read the question and then decide on how you're going to write it. So if I had a biased coin, for example, that I was testing, at the end, if I rejected my null hypotheses, I might say then there's sufficient evidence to show that the coin is biased in favour of landing on heads, for example. Okay, and that is then essentially how we finish. So conclusion in context of question. Very important that you do that at the end. That's how you finish your question. But of course this is far easier to explain with an example. So what I've done is we'll start off with a straightforward example, then we'll look at a past exam question. So as this is a straightforward example, you'll notice that there actually isn't a test statistic within this. It's a very basic one. And we're already given our null and alternative hypotheses. Okay, but I will start at that point. So what I would do is, even though it's given to me, normally you'd work these out, but let's put them in. And you can see that this one is a less than, so we're expecting it to drop. So our next sentence will be assuming H0 is true. So if H0 is true, then what we can say is X is, in this case, binomial. We know it's here. So it's 20 and P is 0.15. So we always assume that H0 is true. And for common things like dice or coins and stuff like that, you know the probabilities of, that is that theoretical probability, what you would normally expect to happen. So here I've just brought up the section from the binomial tables. You can of course do this in your calculators as well. And here you can see in the question that x equals 2. So what we're going to do is the probability where x is less than or equal to 2. As for the first method, what we're going to see is we're going to find the probability of the value and see whether it's going to fall within that critical region. So probability that x equals 2 is here. So we can see this is 0.4049. Now, quite clearly, this is above my 5%, isn't it? So you can see that this is greater than 0.05, or that 5%. So in this case, there's not enough evidence to reject H0. And since this is a simple, straightforward question, that would be where we would start, because we've got no way of comparing it to any kind of context. So that's kind of the first way of doing it. Now, let's put that as method 1. Now your second option is finding the critical region. So the critical region for this would mean that we're going to look at the lower values and we want 5%. So what you'd always do is you take within your tables a value either side of 5%. You always do 2 values. So here you can see the 0 and the 1 represent values either side of 5%. So what I can say here, probability when x equals 0 is 0.0388, and the probability when x is less than or equal to 1 is 0.1756. And we can see that this one is less than our 5%, whereas this one is greater than our 5%. So that means that our critical region, so therefore the critical region is x equals 0. Obviously, most of the time it's less than or equal to maybe, or greater than or equal to, but when it's 0, you know, you can't have anything less than 0, so just x equals 0 is fine. Now, why is it important to always take 2? I'd say it's 1 is a good way of demonstrating, but 2, in some questions, the question will actually ask for what's closest to the 5% or the 1% or the 10%, whatever it decides to use as that significance level. Sometimes the question will ask for which one's closest. Okay, so getting in good habits, that's what it's all about here. So you always set either side. If the question then is just comparing to the significance level, you want the one that's going to be less than that significance level. But if it's looking at which one's closest to the significance level, then you'd be looking at the difference between that and the significance level, and obviously going for the one with the smallest difference. Okay, so it is important that you always just show 2. And then of course after that we can then go, in this case, you know, we've got the value x, isn't it? So we can say since 2, because x equals 2, does not lie in the critical region, then we can go ahead and, like before, say there's not enough evidence to reject H0. And that's the basics behind the 2 ways of doing it. Now, personally, method 1 is how I would approach the majority of these questions. Method 2 I think is particularly useful if the question already asks you to find the critical region, or if you look within the question, the next part might be find the critical region. So if you've got to find the critical region, then it makes more sense to use method 2, so you're not creating more work for yourself. And of course, in turn, then that would save you time, and time is always one of your biggest enemies in these exams. Now, let's have a look at this second example. It's actually from quite an old paper. Can't remember which year now, like 2006, 2007 or something. It's pretty old. Now, Paul grows tomatoes over a period of time. He's found that there is a probability of 0.3 of a ripe tomato having a diameter greater than 4 centimeters. He decides to try a new fertilizer in a random sample of 40. 18 have a diameter of more than 4. Paul claims that the new fertilizer has increased the probability of a ripe tomato being greater than 4 centimeters. Test Paul's claim at the 5% level of significance. So this is a nice question to do. So the first thing we should do in every one of these questions is mention or state our test statistic. Define it. Okay, useful to use X. I pretty much use X every time. You can use Y, most common letters, but anyway. So the test statistic is the number of ripe tomatoes with a diameter greater than 4 centimeters. Now, I also like to mention P, and this is the probability of success. Useful to do because sometimes you might want to switch the question around to look at unsuccessful if the probability was 0.7 and you needed to use tables. That's what you would do. So it's very useful to put that in. You should lose a mark if you miss that bit, but you should. It's a good habit to get that in. Next, I like to state the distribution. So we know we've got binomial here. We've got 40 ripe tomatoes, and we're going to use just P for our probability initially. And that is my initial start. Okay, so test statistic, most important thing there, and then a little bit extra just about what P is and our initial distribution. I then want to go ahead and state my hypotheses. So in this case, H0 is the probability equaling to 0.3. And H1 is the probability. Now, he thinks it's improved, doesn't he? So we're going to say that we think then that P has got better or an increase. So it's got to be greater than 0.3. So I've set it up nicely. Next step now would be assuming that H0 is true. So assuming that H0 is true. Now, of course, you can use the words null hypotheses and things. You can use the lettering. So assuming that H0 is true, X is distributed with binomial, and that's 40 and 0.3. So now I'm saying, right, I'm assuming that H0 is true, and this is the distribution that I'm using. And now I can go with my two various methods. So in this case, I'm going to go with the 18. So we're looking at the probability where X is greater than 18. So this is method 1. Now, greater than 18 is 1 minus the probability that x is less than or equal to 17. So it's 1 minus, and then looking at 17 here, we've got 1 minus 0.9680. That's 0.0320. Next step then is to compare that to my 5% level of significance. So we can say 0.032 is less than 0.05, isn't it? Now, being less than it means it falls within that critical region. So then what we can say is that there is enough evidence to reject H0. And then finally, I need to put that into context. So putting this into context is just about reading that question. So we've got a new fertilizer, haven't we? So new fertilizer has, now it's increased, hasn't it? So increased the probability of a tomato being greater than 4 centimeters in diameter. So something like that. So that's what we're talking about, because that just links back to the question. You know, can just about, I can't quite see it here, but if you go back a little bit, actually I can pull it down. Let's have a look. So you can see here, Paul claims that the new fertilizers increase the probability of a ripe tomato being greater than 4 centimeters in diameter. So we've shown that to be true. So that's all we want to do is state that within our question. So we're talking about then just stating that. We can also then finish with maybe therefore Paul is, or Paul's claim is true, or Paul's claim is correct. Something along those lines. But hopefully you can see now the steps to solving one of these questions. You want the test statistic, very important. This bit a little bit less important, but I think it's worth having in there, especially when sometimes you might want to look at failures rather than success. Your null hypotheses, and then of course, assuming it's true, your new distribution, what it should be, and then you are checking it. Now, this bottom bit here, what I'm going to do is I'm going to redo the question from this point and show you what you can do if you use method 2. So if we got to this point and instead we wanted to find the critical region first, what we would do then is we'd go up to our 5%, and for method 2 I'll do this in purple, the difference part. So I want to do 1 minus 0.05, 0.95. Now the reason I'm doing that is because we're looking at the greater than, so we're looking at the upper tail. If I was looking at the lower tail, I could just look at 5%. Now looking at the upper tail, we got 0.95, and I'll find the two values either side of that. So here we can see either side of my 0.95, and that's where I would start. So probability x is less than or equal to 16 is 0.9367, and the probability that x is less than or equal to 17 is 0.9680. Now of course we want to do 1 minus this, so 1 minus 1 minus, which will also mean that I'm doing 1 minus these probabilities, isn't it, to keep this the same. And 1 minus x being less than or equal to 16 is the probability that x is greater than or equal to 17, isn't it? And equally, 1 minus the probability that x is less than or equal to 17 is x is greater than or equal to 18. And what I want to do now is find out these two values. So the first one is 0.0633 and the second value is 0.0320. And what I can see is this is greater than my 0.05 or my 5%, whereas this one is less than my 5%. So therefore my critical region is x being greater than or equal to 18. So let's go back into the question. I'm just going to move it down a second so you can see. The next value is 18. That's the value we have to test. So going back in now, we're just comparing that. So we can clearly see that 18 lies within the critical region. So 18 lies within the critical region. And now we can go ahead and say, yeah, there is enough evidence to reject H0 and so on like before. So I'm just going to copy and paste that in there from the previous one. So enough evidence to reject H0, new fertilizer has increased, blah, blah. Okay, hopefully that's okay. The bit in purple there is obviously the difference. So you have the option of finding the critical region, then seeing whether that value lies within it or not. Or equally, method one, just testing it and then comparing to that level of significance. Obviously, in this method, if it lied without or outside the critical region, say the value that was in the question was 17, that would be outside of the critical region. Therefore, then we wouldn't reject H0. So we would say there's insufficient evidence to reject H0 and so on. And we would then go on to say the new fertilizer has not increased the probability and so on. Does that kind of make sense? So that would just be a, if we had a different value to 18. And that is, I think, everything you pretty much need to know at the moment. So what I've done here is I've put 4 questions in the rest of the video, answers at the end as usual. First question, just a very basic, straightforward one like example 1. Next 3 questions are all past paper questions. They're all fairly old questions. I just trying to ensure that I got just one tilt test questions for you to try. If you're enjoying this video or any of my videos, don't forget to hit a like, subscribe, comment down below, and I will I'd like to say I see you in the next video, but I don't really show my face. But anyway, good luck, comment down below, and don't forget to subscribe.